So we're just going to spend a few minutes here going over the answers to Module 9 homework on FX risk. First part was pretty straightforward, just really looking at how we can calculate different FX rates and other kind of related information. So let me pull up my Excel file so you can see my calculations. So here you can see question 1, just kind of given the data that we had. What you'd have to do first is figure out US dollars in terms of euro by just kind of inverting euro in terms of US dollars. Once you have that, you can just multiply to get US dollars in terms of yen. Should give you an answer like that. Next, we have the price indexes that were given. And so simply dividing the US index by the European index. Next question, we were given some interest rates and a spot rate. And so to calculate the forward, we're going to use all of that information in an equation that looks like this. Next piece, we have a figure that was given and a dealer quote. Now the key here is to know that if the smaller number is in front of the larger number, then you'd go ahead and add those numbers to the figure. So that's all I'm doing here. 1.70, add 92 pips, right, at the end there. And for the offer, adding 97 pips to the figure. The fifth question here looks at how you calculate the forward FX rate. Not even how you calculate it, but given a dealer quote. So this time we have the larger number in front of the smaller number, and of course that means we have to subtract these values, these pips, from our answer from above. So that's what I did here. Just took 1.7092 minus 45 pips and 1.7097 minus 37 pips. So that gets you those results. And so next, looking at part 2, we have some questions related to kind of some data that we have, daily FX rates. The first question in part 2 asks for the historic annual vol, and that's pretty straightforward. I think everyone was able to get that. But then it gets more difficult when we're asking for you to solve for the 95% VAR based on historic volatility and also based on the implied volatility from options. So let's take a look. So you had this data. I'm going to jump down. We have our daily vol. Simple to calculate, right? Just calculating the STDEV function is used here. We can then calculate the annual vol by taking that daily vol that we have and multiplying by the square root of 252. Again, 252 because it's trading days in a year. Next part, though, says, all right, we start with $1 million in wealth. We have to convert that over to euros. So I'm just using that most recent FX rate to do that. We're given a 2% rate of return. We're given a forward rate. So we want to then calculate the ending balance in euros. And so really that's pretty straightforward, just taking our euros from here and multiplying by 1 plus the 2% return. So we get a value, but next we have to figure out the confidence interval, the 90% confidence interval. And here we're trying to assess what's the FX rate with 90% confidence, right? So the lower bound, we're going to use the forward rate that we have here. We're going to multiply that by, and again, because it's continuous time, we have E raised to 0 for the mean minus 1.645 since we're using 90% confidence times the annual vol, right, the standard deviation. That gives us the lower bound, the same equation except we're adding instead of subtracting here to get the upper bound. And those are our FX rates with 90% confidence, right, upper and lower bound. So the lower bound is what we want to look at here. And if you want to convert this over to dollars, you take your euro, multiply by the lower bound. And that's going to give you the lower bound in dollars. That's the balance in the account. And so what's the VAR? The VAR is the potential loss. So what you really want to do is take this value minus the 1 million to get the loss, right, which really is $185,084.48 with 95% certainty. That's our VAR. Question 3 goes through a very similar exercise. It's just here we're using this given 18.7% option implied vol. But otherwise, it's the same. So again, just calculating this the same way, but our upper and lower bound is going to be different because we're using that new volatility, right? So same idea otherwise, and the VAR turns out to be significantly higher, right? A greater potential loss, significantly greater, because we have more volatility. Now, part 3 was a bit tricky. And so not many of you were able to calculate this, but basically what you wanted to do, the challenge question is the tough part really here. What this ends up looking like is it should have looked like this. So you'd have to calculate the notionals, and then you can calculate kind of that monthly payout on this side. How do you calculate the notionals? Well, let me pull up my calculations. How do you calculate the notionals? Well, you're given this information, right? This is given in the problem. So you know the notionals in euros. But for US dollars, you just take that exchange rate that's given, multiplied by the notionals in euros. And then to figure out the dollar payout, well, we know it's monthly. And so we're just calculating that through. And so later, if you wanted to sell for the profit, well, we said there's 3 million in other costs. So we just subtract that out. But ultimately, the diagram I was looking for is something that looks like this. If you were able to get this, you got some extra points. Some of you came close, and I gave a little bit of partial credit if that was the case.